Welcome to all of you. In this lecture, we are going to have a continuation of linear convolution by using the method linear convolution using circular convolution. Once again, this procedure is going to be in the time domain only, but it makes use of the circular convolution procedure to calculate the linear convolution. Let us go through the various steps involved in the calculation. Given the sequences x of n and h of n, step 1, calculate the output sequence length. Capital letter N is equal to length of x of n plus length of h of n minus 1. Second step, make up the length of x of n to n by inserting zeros at the end. Step 3, make up the length of h of n to n by inserting zeros at the end. Step 4. Perform the circular convolution of x of n and h of n to obtain the output sequence y of m. Now, the sequence y of m is of length capital letter N and is the result of linear convolution of x of n and h of n. One more concept we are going to make use of that will be mentioned while solving the problem. When we get the final result, we need to identify the origin. To identify the origin, whatever the method that we are going to use in linear convolution in time domain using the formula, same procedure is adopted here also, but that will be only at the end stage. Now let us go through a problem, the problem statement. Find the linear convolution of the sequence x of n is equal to 1, 2 and the system having the impulse response h of n is equal to 3, 4, 5. So the origins are mentioned. Let us go through the solution. So given the sequences x of n and h of n, let us first identify the length of the sequences. Length of x of n is equal to 2, length of h of n is equal to 3. So that we can observe. Step 1, calculate the output sequence length given by capital letter N is equal to length of x of n plus length of h of n minus 1. So that is 2 plus 3 minus 1. Output sequence length will be equal to 4. Now, since we are making use of the circular convolution to make solution for linear convolution, we must make up the length of x of n and h of n equal to 4. So, in the step 2, make up the length of x of n to n by inserting zeros at the end. So, value of n is equal to 4 and x of n is having 2 elements. Therefore, we need to insert 2 zeros at the end so that the length of x of n will become equal to 4. So, that has been done over here. Similarly, in the step 3, make up the length of h of n to n by inserting zeros at the end. So, we have to make the sequence length h of n is equal to 4. 3 elements are already present. We must insert 1 zero at the end so that the sequence length become equal to 4. And that has been done over here. The next step, perform the circular convolution of x of n and h of n to obtain y of m. In case of circular convolution, the sequence length x of n and h of n must be the same. Therefore, to have that, we have just managed the sequence length equal to capital letter N so that while making the solution itself, the sequence length become equal to N, that is equivalent to the output sequence length. Now let us go through the procedure of the circular convolution, the time domain method of circular convolution. Y of m is equal to summation n is equal to 0 to n minus 1, x of n, h of m minus 1 with respect to n for all the values of m ranging from 0 to n minus 1. So one thing we must observe here, I am not considering any origin position over here, right? So with respect to x of n, these are the values, origin is not mentioned. With respect to h of n, these are the values, origin is not being mentioned. Therefore, while calculating in the circular convolution procedure, origin is not important for us. Only at the end part it is important. Till then origin position is not important for us. Therefore, we are going to take simply n is equal to 0 to n minus 1. So, as usual procedure of circular convolution we are going to follow. We are going to make use of the matrix method of solution for circular convolution, which is going to be the easiest to solve. So, this matrix has been represented and the values are substituted accordingly. So, this is with respect to h of n as per this matrix, and these are the values of x of n as per this column matrix. So after this matrix multiplication, we are going to get the result as 3, 10, 13 and 10. Now this is going to be the final result for us. Representing that as y of m is equal to 3, 10, 13 and 10. Then in the output we must mention which element is the origin. For that purpose, again we are going to use this formula x underscore si plus h underscore si. So x underscore si is going to be minus 1 with respect to this given data, and h underscore si is minus 1 with respect to this given input. Therefore, we are going to get the the position value of the very first element in y of m as minus 2. Therefore, the position of the value 3 or the very first element in y of m is minus 2. So this is minus 2, position minus 1, then this is 0. That's why 13 is going to be the origin. So comparatively this procedure is going to be quite straightforward and quite faster way of solution. But the only thing is we need to take care of the mentioning of origin position once we calculated the sequence y of m at the end. Thanks for joining.